Okay, so this is the video for your radicals test review. Okay, so I'm sorry I'm not there today. Since I haven't been there for pretty much over half the unit now, I think it's only fair that I will let you guys all be able to retake this test. So, since it's a mini test, we'll have plenty of time to also review when I'm back next week. And then I'll also let you guys have a chance to retake this test since I haven't been here for this. Wasn't planning on getting sick earlier this week. So just to make it fair, you can retake it. But we're going to go through some of these questions on this video. I'm not going to go through all of them because I want you to try some. Ideally, I'd like you to try some of them first, and then you can watch the video to check your answers on them. I'm also going to have the key posted for all of the questions we don't do on this video as well. So let's look at question 1, just to kind of review how to solve again. So remember, we need to get whatever either down here is in the radical, we have to get that alone, or here, whatever's raised to the exponent, we need to get it alone. So is it alone on one side? No, it's not. We need to divide by 2 to get it alone. So we'll have x minus 7 squared equals 16. Now it's alone. How do I get rid of a square? I square root it. So I'm going to have x minus 7 equals, square root of 16 is 4. But remember, I always have a plus or a minus when I'm square rooting, or taking the 4th root, or the 6th root, or any even root. We're going to have 2 solutions. The positive one and the negative one. So let's add 7 to both sides. So we're going to get x equals 11 and x equals 3. Those are our 2 answers. So not too hard. So I'm going to leave the next 2 for you to do. Let's look at question 4. So remember, whatever's in the radical, it needs to be alone. Thankfully, it's already alone. So how to get rid of a cube root is I cube it. So I'm going to get 216 equals 3x minus 1. And let's just solve for x. So add 1 to both sides. So 217 equals 3x. Divide by 3. So we get x equals 217 over 3. That's our answer. So I'll leave 5 for you to do. Okay. Let's just quickly look at 6. So again, is whatever is being square rooted alone? Yes. So let's square it. What do I do to one side, I do to the other side. Well, thankfully, since they both have square roots, everything cancels out. So I'm just left with 2x minus 4 equals 5x plus 23. Let's solve for x. So let's get the x's on one side. So I'm left with negative 4 equals 3x plus 23 minus 23. And we get negative 27 equals 3x. Then we divide by 3. What does x equal? Well, x equals negative 9 then. Okay? Let's go to question 7. So looking at question 7, we need to get this alone. So we need to minus 8. So I get 3x raised to the 3 over 4 equals 27. Okay, so we need to get rid of that. I like to just do it one at a time. So To get rid of this 3, it's an exponent, so the opposite of cubing something is cube rooting it, right? So since this is a cube, to get rid of an exponent, we have to take the cube root. So I'm going to be left with 3x raised to the 1/4 equals, and the cube root of 27 is just 3. Now to get rid of the next one, I just have to raise it to the 4th power. Okay? So remember, because our exponent property says we times those together, 1/4 times 4 just equals 4/4, which is just 1. So that's how they cancel out. So I'm just left with 3x equals 81. Now I can divide by 3. So x is going to equal 27. Okay, so like I said, I just prefer to do them one at a time, but you can do them both at the same time. You can just times by the reciprocal of 4/3 if you wanted to for both sides, whatever works for you. Okay, so question 9 is one of the harder ones. I don't want to go through this on the video because we've already talked about it in class, and I want you to try it. The answer key will be on Canvas, and we can talk about it when I'm back. So I want you to try to do this one. Okay. Let's go to our transformations. So, remembering our transformations, the key is everything on the inside of the radical affects x, because it's right next to x. Everything on the outside, and if there's something over here, affects y. The other thing with x is we need to think opposites. So, right here, this looks like we're shifting, right? Whenever we're adding and subtracting, we shift. It looks like we're shifting to the left, but really we're shifting. So we're going to have a shift by 4, not B4, by 4, shift by 4 to the right. Okay, we have to think opposites. Then let's look at here. It's on the outside, so it's affecting y. Since it's timesing, this is multiplication, we're going to have a vertical stretch by 3. Vertical stretch by 3. Okay, let's look at question 2. So again, inside affects x, outside affects y. So we're going to shift right 3, and we're going to shift down 3. Okay, see how this is subtraction. It's different than here. Over here, we're multiplying, so that's why it's a stretch. When we're adding and subtracting, we're shifting. Okay, let's go over here. So, again, inside affects x, outside affects y. So, inside affecting x, that means it's a horizontal. And since we're timesing, it's going to either be a stretch or a shrink. Remember, we have to think opposite. So the opposite of 2, we got to think reciprocal, 1/2. So we're actually shrinking. So a horizontal shrink by 1/2. Okay, so let's go to the other one. We're going to shift, because we're adding and subtracting, we're going to shift up 3. Okay, going to leave you to do the last one on your own. You can check the answer key. So, let's go to transforming our graphs. Okay, so I've decided on your test, I'm going to draw the parent functions on the board with their key points, okay? So here, zoom in a little closer because everything's so small. we have a cubic function. So remember the points of 0, 0, 1, 1, negative 1, 1, and 8, 2. These were the important points to know for our parent functions. Okay? So they were the ones we need to know so that we can transform them. So remember, the order, we stretch before we shift, okay? And we're always going to just start with our x. So let's look here. What's happening to x? Well, x, so yeah, we stretch before we shift when we're talking about the x and the y's. So if I had both things happening to x, I would stretch before I shift. And if both things were happening to the y, I'd stretch before I shift. But since only one thing's happening to x and one thing's happening to y, we're just going to start with our x and then go to our y. So x here, we move right 4. So let's move every single one of these points over 4. Okay? So there we go. Next one, it says we are vertically stretching by 3. So that means every single one of our points is stretching by 3. So we have the point right now at 5, 1. Let's do that one first. That's right there. So 5, 1. If I was to vertically stretch that, that means I'm timesing my y values by 3. It's going to become 5, 3. So let's put that point there. 5, 1, 2, 3. Okay, I have this new point here at 4, 0. If I was to times my y value by 3, it's still going to stay at 4, 0. Okay, the next point I have is at 3, negative 1. So if I times my y value by 3, I'm going to get 3, negative 3. Okay, so remember we're just timesing all our y values by 3. So here our y value is negative 2, times it by 3, we're going to get negative 6. So we can connect the dots, and voila, the red one is our new graph. Like I said, you can keep all the other ones on there. I can tell which one's right, and it also is a way to show your work. So what's my domain? Well, it's never going to change for cube roots. Okay? Let's go to question 15, and then I'll leave the other two for you to do. Okay, so we start with our x's, then we'll go to our y. So remember, parent function for a square root, these key points. I will put them on the board though, but go faster if you had it memorized. So, since it's timesing by x, we're going to be doing a shrink or a stretch. Okay, and we have to think opposites. So we're actually timesing all our x values by 1/2. So let's look right here. This point at 0, 0, if I was to times my x by 1/2, that's not going to move. But what about the point 1, 1? Timesing my values by 1/2 means it's actually going to move to there. Sorry, wrong way. Right here. Okay, and then if I have the point 4, 2, I'm timesing my x value by 1/2. Well, what's half of 4? It's 2. So I'm going to have the new point at 2, 2. Okay. Going to have to move this so I can get my point for this one. So if I have the value 9, 3, half of 9 is 4.5. So I got to move that to 4.5. And so that's what happens when I have a horizontal shrink by 1/2. let's go to the next one. It says we got to move our points up 3. So our new points go 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Gotta erase that so I have room. There we go, and that's our graph. Okay, so just remember that we're timesing by the reciprocal when we're looking at x. And we're either going to be timesing our x values, or if it was a vertical stretch, our y values. So what's our domain? So remember, domain is all possible x values. Well, we go from 0 to infinity. What about our range? Well, our range, we start at 3 and go to infinity. Okay, so I'm going to leave the last two for you. We're going to do just question 18. Question 19 is a lot easier. So we need to write the equation. Some transformations happened. We need to write the equation. Remember, there's only ever going to be 2 transformations. So okay, so I'm going to draw the parent graph on here. It's just helpful to know where our points are supposed to be at. And then 8, 2, and negative 8, 2. Okay, so I'll just draw the points. So that's where our points are supposed to be. Well, what do we know happened here? Well, we can for sure see in order to move those, we're going to have to go up 1 at some point. We're going to have to have gone up 1 at some point. So if I went up 1 though, I would have a point here, a point here. If I look here, I'd have a point here, a point here, and a point here. Okay, the red points are when I went up 1. Well, let's look right here. You notice how here those connect, and here they have the same y value here as well. And if we look over here, these two have the same y value as well. Well, what's the distance between these? Let's look here. This distance is halfway between here and the origin. Here, this distance is halfway between here and the origin. So I'm not changing my y value because their y values are all the same. I'm changing my x values. And what am I doing? I'm having to shrink it by 1/2, right? It's half the distance. So I shrunk my x values by 1/2. So if these are the transformations that happened, let's write our equation. So I start with an x, but if I'm shrinking by 1/2, that means I'm actually timesing by 2, and then I go up 1. Okay? So the ones with stretches are a little bit harder. On your test, I don't think we will give you where it's the same, where since this is a vertical shift, we won't give you a vertical stretch as well. We'll make them different. So either your shift will affect x, if your shift affects x, then your stretch will affect y. Okay, if that makes sense. So I'm going to leave the rest of this for you to do for homework. I'll have the answer key on Canvas, and then you can ask me any questions when I get back. So we'll have plenty of time before the test comes around.